Was graph 2x squared minus 6x minus 4 by finding the vertex and two other points immediately to the left or right. So I guess we'll find the vertex. It's x equals opposite b. So what's opposite b? 6 over twice an a, twice a 2. So that's 6 over 4, which is 3/2. And if you're not making tables, perhaps you should. Okay? The vertex is kind of a middle point. That's what a vertex is. And I've been teaching you to move 1 unit left and 1 unit right. If you take away 1 from 3/2, what do you have? 1/2. Probably got a funky number, still would have worked. Actually, probably would have worked better than this.
It was -8.
Yeah, it probably worked better than this. If you move 1 unit right, what do you have? 5/2. Now, there's a side reason why I'm teaching you this, and I'll try and show you today on the graph. But those are x values, and if I have x values, how do I get y values? Plug it in. I'm just going to use a storage feature. Take a half, store it to x, and you can play along, or you can just, never learn how to use a calculator. It's up to you. 2x squared minus 6x minus 4. Got negative 6.5. But I will show you why I kind of like the unit left, unit right here on this one. Take a 3/2, store it to x, second enter, so I don't have to retype all that stuff. Negative 8/2. Now what's going to be true about this top one and bottom one? They're going to be the same. It's called symmetry. So I don't need to do it twice. Vertex was at 3/2, negative 8.5. I'm going to have to make these smaller. Here's the vertex. And then I went to the right unit, and I went to negative 6.5. So it's like right around here. Went to left unit, about right in there. Now, my grid's a little hard to see, but what's A? 2. I rose 2, ran 1. Rose 2, ran 1. That's why I like the unit left and unit right. Only the unit left and unit right will show the actual A value. That's fine. Only the unit left and unit right will show the actual A value. Everything else doesn't.
Yeah, I kind of thought I got that wrong.
No, it's just an ugly problem. Anyways, there's that guy.
But the just 1 and 2, is the 2 things, you just got negative 8.
It's fine too. You need 3 points. What else you want to see?
Number 8. Number 8.
8.
Yeah, and
I'm already on the back. I'm already right there. So we'll just use this thing. All right, so where are your x-intercepts? Negative 1 and 2. I mean, that's just as simple as changing signs. Okay? We go ahead and make a table. Trey, x-intercepts happen when y is what? So, what am I going to put for the y values next to these x-intercepts? Zeros. That's 2 of the 3 points I need. The other point you go after is your vertex, which it tells you how to find, doesn't it? It says the x-coordinate of the vertex is going to be negative 1 plus 2, sitting over a what? 2. That's a half, last I checked. Now you're going to have to do a little work here to get y. What are you going to do with your half? Just going to plug it back in. Do I need to use a calculator on that? Yeah, we will. Negative 2, I'll just do the storage feature. 0.5 stored to x. Negative 2. You guys don't play along, so whatever. Like the number of kids who miss problems because they don't know how to use a calculator is ridiculous. is absolutely ridiculous. 4.5. Let me show you an example of that. Let's see if you'll play along. Just ignore this problem for a second, okay? Don't do any math in your head. Don't do any math in your head. Nothing. I can write. Type that in the calculator. Just type that in the calculator. No math in your head whatsoever. Just type in the calculator. Pretend you're that kid who doesn't know a darn thing, can't do anything. Just type that in the calculator. I realize the way these numbers are, you can do some of that in your head. Don't do any of it in your head. Just type that in your calculator. Ty, what'd you get? Grant, what'd you get? You typed it in just like that? What'd you type in your calculator? Ah, good for you, Grant. That's right. I told you not to do that. There are a lot of kids who cannot do anything without the assistance of a calculator, and they're going to have to learn a double wrap. That's why I do stuff up here in the calculator. You should be playing along. You know, Ty probably would have figured out that's not right.
Oh, no, it's 8.
A lot of kids would just accept that as gospel truth because their calculator told them that. And Sean, didn't you make that mistake the other day? Well, the mistake we just made right here. Yeah, you're going over something like on a twin, and you asked me about it.
Oh, yeah, because
You got to be very careful when you use a calculator.
when I wrote it down, I didn't put the parentheses, and I wasn't thinking, so I just typed it in like that.
You got to be very careful. Let's see here. So now it's time to graph this thing. Back 1, up nothing. To the right 2, up nothing. And the vertex is at 1/2, 4.5. So it's about right there. Then she opens down. She's got to pass through those two intercepts. Anything else you care to see? 11. That's right, 11. I need to be stopping soon. Let's see, you're supposed to complete the square. Notice that it said complete the square. If I look at your homework and you do the quadratic formula, you're not getting credit. It says to complete the square, kids. So the 5's where it belongs. How about this 4? What do you got to do with it? You got to divide everything out by 4. And don't use decimals. Nowhere, unless we do an applied problem, like when something dies or hits the ground, I don't use decimals, do I? Don't use decimals at home. Just leave it as 5/4. If you're writing 1.25, you done missed the problem. I mean that. It's done missed as far as I'm concerned. Now, the steps are there. What do you take half of? B. So you take a 3/4 and you divide it by 2. You can do that in your head real quick just by moving that 2 right there. I think I showed this the other day.
Yep.
That's 3/8. Notice I'm writing this stuff down. You should be too. Otherwise, you just have a line underneath this with numbers that you don't know where they came from. What do you do with that 3/8? Square it. When you square something, you just multiply it by itself. What's 3 times 3? 9. 8 times 8. What's done with your 9/64? What do you do with it? It's in the steps. Add it to both sides. Now, you're not supposed to sit here and do descent check on this. How does this piece factor? X plus 3/8. Because you got it right there. The day you took notes, I drew those arrows. A lot of kids didn't. They don't know how this works. Congratulations, you just lowered your grade in your 10 points by not knowing how to complete the square. Well, I try to tell kids math is cumulative. This is a cumulative course. Everything builds upon everything else. You can't have a missing step on your ladder. It's just not going to work. You got to add 5 quarters and 9/64, so that's going to be ugly as can be. Something over 256. What, 320, 356 maybe over 256? Sounds right, that probably reduces. But I'll just cheat versus missing it and getting it wrong. 89/64 is a reduction. Did you get it or did your calculator get it? Okay. Give credit where credit's due, son.
Well, if I got it, I can use it.
How do we counteract squaring?
Sure.
Square rooting. So this will free up x plus 3/8. Can you take the root 89? No. Plus or minus root 89. Can you take the root of 64? Yes. What are you going to take away from both sides? You go right. So x is going to be a negative 3 over 8 plus that root 89 over 8. Or, what's the other one? Minus 3/8 minus root 89 over 8. I actually need to stop there. I'm sorry if there's more you need to do, but I'm going to stop right there. Because I need the time. You need the time. I'm going to do these 5 problems with you, and then we're going to do a quiz. And because I don't want you all to fail, I will let you have this out. First thing you have to do on that problem is divide by 4. For some reason, I think you added 4. I don't know what you did.
Oh, okay, I see what I did. I didn't divide the whole problem out before I did it.
You divide one thing, you divide all things. But we took half 3/4 to get that 3/8. You have to run out of focus, man. I got one. Yeah, I'm going to try and run through these real quick so you guys can take a quiz. And because I don't want you all to fail, I will let you look at this one and take a quiz. Yeah. Pretty much. No, can you go back crap either? No. I want you guys to have 20 minutes to answer 5 questions because you ought to be able to do that. Now, the first thing up here on your little practice sheet is x squared minus 121. This is what we call a difference of 2 squares. It is a squared minus b squared. It will factor as a minus b times a plus b. A and b are the things that are squared, kids. What do you square to become x squared? So you're thinking a squared is x squared, so a must be x. You're thinking b squared is 121. You ignore the darn sign, just 121. What do you square to become 121? B is 11. Guess what you have now? All you need. You just plug into that. Nothing more. So this factors as x minus 11 times x plus 11. And we are solving. It doesn't say factor, it says solve by factoring. So we use the little cover-up technique. I'll take my little pinky here. X minus 11 is nothing. What's x? 11. X plus 11 is nothing. What's x? X is negative 11. That one's done. Now the next one says factor. I swear, I'm not going to swear to God because I don't like to do that. I swear on Austin's life that if you solve number 2, I will count it wrong. Does it say solve? Do you see an equal sign? You better hope they don't solve. Reminds me, I forgot to start recording. I'll do that in another class. It's guess and check technique, kids. You're thinking about how you foil things out. That's all you're doing, right? When you FOIL, what does it take to create a 5x squared? It takes a 5x and an x, okay? All it takes. Because you link those together and you get your 5x squared. Now the end has some possibilities. You got to play with factors 8. There's more than one set of factors for 8. Give me 4 and 2. You got an idea where you want them?
4 behind the first x, or 1x, and then the 2 in the parentheses.
She's actually halfway decent at this because that's the correct order. Because the outside creates 20 of them. The inside creates 2 of them.
You would have to make the x minus 4, it'd be x minus 4 and 5x plus 2.
Yeah, because that creates a negative 20x on the outside and positive 2x on the inside. And what is 2x minus 20? Negative 18. That's it. I don't want to solve. You're done. Plain and simple. 3 is completing the square. And I've got, the shortened version of the instruction set here for you. It said 8 steps. I just narrowed it down to 4. Because we just do some stuff at the same time. Step 1 is divide all terms by a and move the constant to the right-hand side. But you need to do the division first. Not last. Do it first. This doesn't actually matter. So if you divide by 5, you get x squared minus 6x. And you've got this 8/5. What are you going to do with that 8/5? Put it on the other side. Now you're probably already scared to death of this thing because a fraction showed up. Nobody freaking cares if there's a fraction. You have TI-84 in front of you. Learn how to use the thing. What are you going to take half of? Take half of b. So off to the side somewhere, you're going to take a negative 6 because b is negative 6. All right? And you're going to divide it by what? And you're going to get negative 3. What are you going to do with that negative 3? You're going to square it, and you're going to get 9. What do you do with your 9? Notice Mr. Milbrath hadn't used a decimal. You don't either. How's the left-hand side factor? X minus 3 what? Squared. Because it's right stinking there, kids. It's right stinking there. You got to add your negative 8/5 and 9. You'll get 37/5. No, you won't. Yeah, you will. 37/5. Now, this one's got kind of an ugly issue going on, and if you don't go all the way with it, I will dock points. You're going to counteract your squaring by doing what? I'm going to rewrite that as the root 37 over root 5. I don't remember if your quiz one does this or not. This one's kind of ugly. It's a practice problem. When you counteract squaring on the left with a root, what happens? Cancels out. Now, I'm going to work with this number off to the side. This number is fugly because it has a radical where? On the bottom. How do you fix that? By root 5 over root 5. If it's just a simple radical on the bottom, you just multiply the top and bottom by whatever that radical is. Now, the bottom will become a 5. The top is the product of 37 and 5, which is 185. So it becomes a root of 185. Now that thing right there, I'm almost certain is prime. Its factors are 37 and 5, so it's a prime. You can't simplify that radical. It's done. Why'd I include plus or minus? There's 2 answers. It's x squared. That's where you throw it in at. You always throw it in at when you start taking square roots. Last thing is to add what? So we got 3 plus root 185 over 5, or 3 minus root 185 over 5. And if you write me a fugly answer, mathematically correct or not, I will dock points. I don't do fugly. You shouldn't either. Moving on. solving a complex number system, which means you may have imaginary answers, kids. All right, by taking square roots. What do you guys want to do first? That's always what you do. You do the easy stuff first. That's what I've been trying to tell y'all. What else is easy to do? Divide by 4. Maybe I should show this stuff, because I know a lot of kids just have no math sense whatever, but they're negative 36 divided by 4 is negative 9 all day long. What's the opposite of squaring? Square root. Ty, is that real or imaginary? Oh, you weren't here that day, were you? No. It's imaginary. Doesn't read. It's not real. Let's talk about this root of 9 off the side for Ty. The root of a negative 9 is the root of a negative 1 times the root of a positive 9. The square root of negative 1 is defined to be I. And what's the root of 9? 3, which is freaking fugly. I3 is a really old iPhone. Call it 3i. You see a negative, Ty, you put an I in front of it and you think about the number positively. Seriously, that's it. You put an I in front of it, you think about the number positively. So, what's the left-hand side become? X plus 3 equal to plus or minus 3i. Then you take away 3 and you're done with this thing. X equals a negative 3 plus 3i or negative 3 minus 3i. Notice I'm writing out both answers every time? You should too. I want you to write both answers distinctively, separately. I've been doing it every time, haven't I? You could factor that if you wanted to, but you don't need to. You could pull a number. You don't need to. It doesn't do any purpose. What's up next? The quadratic formula. It does say PS, one-sided. So I guess we'll do that first. Where's that 10 belong? Left-hand side. Now, your quiz will not do this. Don't think you can do this on the quiz, because you can't. But on this problem, could you make the numbers smaller? You could pull a 2 if you wanted to, and it is optional. Should I do it? For y'all's sake, probably not, because then you'll think you can do it on the quiz, even though I said on the quiz you can't do it. So I'm not going to do it. What's A? Yeah. Huh? Because the numbers aren't as pretty. A is 6. What's B? What's C? Negative 10. And then you're plugging in, which for some kids yesterday, like this was just the hardest thing they'd ever done in their life. It says opposite B, so that positive 12 becomes negative 12. And you do have to show me how you plugged it in. It says show me, so I can at least give you something. Are you the kid who can at least plug in numbers correctly? What I'm looking at here. 12 squared minus 4 times A, which is what? 6 times C, which is negative 10. All sitting over twice of what? 6. These numbers, I don't know, you can do them in your head if you want to, but when the numbers start getting big and I start getting lazy, I type in that discriminant in the calculator. And I'm typing it in exactly as it's written. I'm not doing anything differently here. It's written like that, so I'll leave it like that. There's a 528 left in that radical, okay? No, it's 10, isn't it? Put 16. 384 in that radical. Is that what you guys got? So part 2 is where you show me the math. You have a negative 12 plus or minus root 384. You should be able to make the jump from here to here without doing anything extra. You have a calculator in front of you, kids. All sitting over what? 12. Now, it does say simplify if possible. It does say that. What's 384 end in? Ends in 4. This might do better than that. What you do is you divide by numbers that you can take square roots of, like 16. I can take the square root of 16. Happens 24 times. I'm going to go bigger. 64 is the one. Because 4 enters 24 4 times, and 4 times 16 is 64. So I'm going to break it down into 64 times 6. I'm going to do that off to the side. The root of 384 is the root of 64 sixes. And the root of that 64 is what? 8. That's 8 root 6. You know, I'd give you partial if you get this far, but if you want full credit and the radical simplifies, you simplify it. 8 root 6 all over 12. And again, we're going to break this apart into its two distinct answers. A negative 12 divided by 12 is a negative 1. 8 twelfths. Both divisible by 4. That's 2/3, isn't it? So plus 2 root 6 over 3. And the other guy is that negative 1 minus 2 root 6 over 3. Took a little longer than I had hoped it would. But you can have that on you. Now you can take